We're going to look at an ambiguous case, this time the one that has two solutions. So let me start you off. I've covered the picture this time at the start because I'm going to walk you through the information they give you. It says find two triangles for which A is 45 degrees. I'm going to start there. I know that angle A is 45 degrees, so I'm going to say that's about 45. Now, how we could have two triangles here is, let me clone this. Where is clone? There it is. And so how I could have two triangles is this. Angle A is here in both cases, and it is 45 degrees. Now that's what they've given me. Now they say A across is 18. Now what that means is, what I don't know is A could come this way and be 18, or A could come this way and be 18. Both of these are the same length. It's just one connects to the triangle this way, the other connects to the triangle that way. And we don't know which is the case. Now as we label this across, it says C is 24. Now what's the other thing that does not change? Well, it's this side. So this is the one that's 24 in this case. So this would be our C, this is our B, as I have drawn this. Now you can see their picture here is a little bit cleaner, and you can see how you could have two different, this is 18 or this is 18. That H is not 18 there. The height is not 18. So that's what we have here. So we have to solve them both. So how do we do so is a good question to begin with. So let's start with our normal sine rules. If I have a completed set, which I do, I have that sine of 45 degrees over 18. That's a completed set. Could solve for anything else. Now, I'll look for this angle C. So I'll say that's equal to sine of angle C here in degrees over 24. And by the way, we would start the same way for this triangle. So what's my first step? Well, I want to cross multiply and divide. So I'll have 24 sine of 45 degrees equals 18 sine of C. Now I'm still trying to get C by itself, so the first thing I do is I divide out this 18, which will leave me this, and then remember, the next step I'll combine in one. If you need to go back and watch example 3, then do so. To get this C by itself, I'll need to flip the angle on the side. So really what I'm going to find out with is to get C by itself, I need to flip these two, and to do so I need to take the sine inverse. Will equal the sine inverse of that. 24 sine of 45 degrees divided by 18. So we're going to go to our calculator and type this in. So let me get where we can see this here. I've got, I forgot to do sine inverse out front. I'm sorry. Trig, sine inverse. And now I need to delete this. Okay. We had in the numerator 24 sine of 45. 24 times sine of 45 degrees divided by 18. And we get that it's 70.528, we'll say 70.529 degrees. So C equals 529. 529 degrees. So as I started, I thought I was solving for this triangle, but I actually solved for this one. How do I know? Because look, this is over 90 degrees. This is less than 90 degrees. So we just discovered this angle, and it says round psi lengths to the nearest tenth, and angle measures to the nearest degrees. This C is actually going to be about 71 degrees. Now, so how do you find this one? Well, the truth is they're both the same distance away from that height as one another. So they're both the same. It's just they're going, one is greater than 90, one is less than 90. So here's what I need to do to find this out. I would take the 90 degrees, that would be a perfect right angle, and say 90 minus 71, and this gives me 19 degrees. Well, what does that have to do with anything? That means this angle here is 19 more than 90. If this one's 17 or 19 less than 90, this one's 19 more than 90. So when I add that up, I should get, okay, now I made that a little bit better. Another way of thinking about it is like this. If you made this a triangle, that 71 is there. Well, here, if you made this a triangle, the 71 would be here, and you would subtract from 180. Again, you just get 109. How am I getting 109? Well, because I'm taking 90 degrees, and I'm adding 19 to it. So either way, you end up with 109 degrees. That's what this angle is there, 109. Okay, so now, progressing from there, I've got angle A, angle C on both of these. How do you find angle B? Well, in the first case, and I'm going to need to divide this triangle at this point in time, or this working space, to solve for both here. We'll do this here. This will be the triangle on the left, and this will be the right triangle. Okay, on the left, to find angle B is, I would say, 180 minus 109, which is angle C. That gives me the 71 degrees, and then you would subtract the 45, which, remember, was angle A, and that leaves me with 26 degrees. That is angle B. So now we know here B is 26 degrees. And now I'll do that on this right triangle. I start with 180, and I subtract the 71 degrees, which is this one's angle C, and I'm left with 109, and then I take away the 45, which was angle A, and what am I left with? 64 degrees, I believe. That would be my angle B. So this was here, 64 degrees. So now the only thing left to find is this side length on both of these. So on the left triangle, I would use, and let me divide this so we don't get lost in the work we've already done over here. I'm going to take that there and cut it that way. So on this side, what I would do is I'll set up that sine of 45 degrees over the 18. I'm starting with my original completed set, is going to be equal to, I need to find this length, so I need to use this angle. It should be equal to sine of 26 over, or lowercase b here. And on this side, it'd be essentially the same thing. The only thing different is, instead of using 26 degrees, we're going to use that 64 degrees. That's the only thing different. Since I have more room to work over here, I will insolve this side, and I'll cross multiply and divide this side. So I'll do the actual math over here. You would have 6, excuse me, that's not a 6, that's a b. b times sine of 45 degrees equals 18 times sine of 64, and that's a degree. And the last step here would be divide by sine of 45 degrees. That should give me what my b is. So I'm going to go to my calculator, and we're working with a fraction here. 18 times sine, was it 64? It was 64 degrees, and all that needs to be divided by sine of 45. Okay, hit enter, and I get the 22.9. In this case, C is 22.9. So I'll put it over here. C equals 22.9. That would be here. And now, defined, this one, the only thing that would be different is I'm substituting 26 in the place of 64. So what I type in the calculator is I'm just going to do 26 here. I'll kind of skip the steps. So I told you I was insolving. I will, just because that's what I told you. But really, all you'd have to do is solve or substitute 26 here. So what I'm trying to say is this: if you substitute 26, since we've already done this one, That should be the answer. But I told you I was going to insolve, so I will. So we'll go menu 3-1. That's where you get to insolve. And we had a fraction. And we had that sine of 45. Whoops. Sine of 45 degrees. What I did there, if you were just wondering, is I typed in sine rather than going to the button. Over 18 has got to equal, we have another fraction, sine of 26 degrees divided by some amount. We called it the letter B, so I'll do the same thing here, and then you do comma B. Now if I did our work correctly, we should get this exact same answer, and we do. So over here, the answer will be 11.2 when we round. So here, C is 11.2. C equals 11.2. That would be this distance there. And that's how you would solve it. I know it's a lot of work, but sometimes in mathematics it takes a little bit of work. Here's one for you to, oh, I forgot that I had these slides even available. So I have this one for you to try. You can go through it and see which ones you come up with.